Is there a way to see how many people are joining us online? Just the 7 that are down there in the bottom right-hand corner? With the link. I see. Got it. Okay. Clearly, I don't know all the technical details, so I'll just very quickly welcome everyone and say thank you for joining a relatively short lead time RAL presentation, so I know that probably availability was somewhat limited. So thanks everyone for joining here in person, and then also probably the folks who are online, because probably like many of us, you want to escape outside to either play in the snow or escape and like curl up in your couch and just have one of those days. So we really appreciate the folks who are able to join us. I'm Julie DeMuth. I am the lead of the Convergence Science Program, which is at the directorate level, and we have an amazing opportunity today, so I want to say thank you to everybody who helped convene this presentation to share some details about the Convergence Science Program and everything we've been working on for the past 9 or 12 months with RAL. And with that, I probably won't say a whole lot more. I am here to answer questions, but Chris Wers is going to kind of take things from here. And then we have many folks from RAL who are part of the Convergence Science Program who will be presenting to you all today. So take it away, Chris.
All right, thank you, Julie, and thanks everyone for helping get this set up. I do have a note that we should be recording, and I forget to record things often, but I'm getting a thumbs up from tech. Awesome, okay. So we have this as a resource down the road. My name is Chris Wers, and I am part of the Convergent Science Program as well. It's one hat I have, and then I'm also a social scientist in M-Cubed, working on risk communication stuff with Julie DeMuth. And so today, this meeting is focused on the Convergent Science Program's efforts for strategic communication with the different labs. So you're going to hear a lot from your team, what the program is, where we're going. But just to give an overview of what we're going to cover. We're going to cover the program. We're going to cover on what is convergence research, make sure we're all on the same page of what that means. Some motivation, scope, and vision for the program, kind of where we're going, what that means for you all. Introduce your team, your community of practice here, as well as then open up to have some discussion time. And if you have questions, you can let us know, put them in Slido here. Whatever you need to do to communicate us, we'll break and have discussion wherever you want to. It's hopefully more of a conversation as we can. We got some stuff to cover, but we'd love to hear from you all. And also, we pulled this together pretty quickly where we had this is the best opportunity for strategic planning. So hopefully it goes smoothly. We have people online, we have people in the room presenting, so bear with us with a little bit of grace today, as much as you can. And then what I want to do is just give a quick introduction to the Convergent Science Program. And so it's a little bit of a chicken and egg here thing. We want to talk about the program, but what is Convergence and why is our program? But just at the high level, Convergent Science Program was started by the directorate. And really the goal there is in bold, to accelerate NSF NCAR's leadership role in enabling and conducting convergence for the Earth system science community, right? So that translates to a vision where NSF NCAR is a place where convergence research for the field of Earth system sciences is deeply understood, valued, and supported, scientifically, culturally, and financially. And we'll talk more about what this looks like later on. But just to highlight, the team involves a lot of folks. So Julie's the lead who you heard from here. We have folks from across different labs, but we highlighted the RAL folks here for you. So Brenda and Olia are both on the leadership team representing RAL, and then we have at least one ambassador, sometimes 2 from all the other labs, and then 3 from RAL, just considering the focus of RAL and the kind of the connection with Convergence. So just showing who your representatives are. And you'll hear from these folks for the rest of the day. I'll clean up the slides, but mostly these are the people you'll be hearing from at the end. And just to kind of hit on this too, something that we talk a lot about in the Convergent Science Program are values. And these aren't things that are unique to Convergent Science, but these are things that we feel are really important for both Convergence, but also how we're approaching this. So thinking about appreciation, humility, and purpose, egalitarianism, open-mindedness, patience, and kindness, as well as rigor. So all really important factors for doing this work, but also operating the space as a program. And so there's a lot of text on here. You've done a slam poetry version of this for the interest networks. If you're interested, I've read it all, but mostly leaving this up here for reference, and we'll share the slides with folks as well. But I want to pass it to Brenda now to talk about what convergence research is, right? So I should be right in the transition, and just let me know, Brenda, when you want the slides advanced, and I can send it forward for you.
Sounds great. Can you hear me?
Yeah.
Okay, great. Here we go. So yeah, thanks everybody for the opportunity to join the group. I'm Brenda Hoppy. I'm a fairly new project scientist, social scientist working in RAL with Olia. And for the next couple slides, I'm going to be giving you a very high level explanation of what convergence research is, a little bit about what it isn't, and then some key characteristics, hopefully just enough to spark a more in-depth conversation at the end of our presentation here. Next slide. So our program, the Convergence Science Program here at NCAR, embraces the definition of convergence research that was put forward by the National Science Foundation. In 2016, NSF identified convergence research as one of its top 10 big ideas, and it has plans to invest approximately $30 million in growing this emerging field. So there are a few key characteristics of convergence research that NSF highlights. Next slide. According to NSF, convergence research is a means, it's a process or an approach to solving some of the world's most vexing research problems. And these are problems that are highly complex, often multifactorial, that cross systems, sectors, and disciplinary boundaries, and especially those problems that are focused on the needs of our society. Convergence research is driven by specific and compelling problems that arise from deep scientific questions or pressing societal problems. Like I said, examples of that are climate change, pandemics, and food security, just to name a few. And convergence research involves deep integration across disciplines, intentionally bringing together intellectually diverse researchers, interweaving their disparate theories, data sets, methods, and technologies that facilitate an end product that could never have existed without the accumulation of these different disciplines. So in my mind, convergence research is synonymous with the concept of Gestalt that refers to creating a whole that is greater than the sum of its parts. Convergence research is nothing if not a means toward innovation, and that is evidenced by many of its products, which can include new frameworks, new paradigms, fresh best practices, new technologies, or even new disciplines. My discipline, environmental epidemiology, and my different spheres of practice, which include geohealth and biometeorology, are all convergence research products. They develop from the intentional weaving together of knowledge, data, and methods from very diverse disciplines: environmental science with epidemiology, public health with geology, biology with meteorology, to tackle some major societal challenges like legacy pollutants in drinking water or extreme heat impacts on the energy grid and risk for vulnerable populations. Next slide, Chris. So some elements of the convergence definition are not solely specific to convergence research alone. For example, there are many scientific approaches that center societal needs, but they are all hallmarks or criteria that are consistent with convergence research. Convergence research is very much a team effort. It decenters any singular disciplinary perspective across the shared problem space of a research effort. And it takes time and effort and a high tolerance for uncertainty and iteration, because as that problem space broadens to include multiple disciplinary perspectives, the problem itself then becomes non-stationary. And by that, I mean that that problem will inevitably change or morph due to the honest, deep consideration of these various disciplinary perspectives. And then moving into the next slide, Chris, it can be hard to distinguish convergence from other research approaches. You can probably click through all that animation, Chris. Thanks. So it's important to emphasize that one approach is not necessarily superior to the other. It really depends on the research question and how it's being scoped. So unidisciplinary research goes deep into a singular discipline or field, while multidisciplinary research may bring together multiple disciplinary experts, but they're still staying within the lane of their expertise. You don't see that intentional intermingling of data or methods or theories, and researchers often stay in their disciplinary silos, conducting their work in relative isolation from their other colleagues. With inter or transdisciplinary or convergence research, here's where you see that intentional intermingling of methods, data, or theories into that greater whole that is beyond just an accumulation of different data sets or topics piled on top of one another. That purple oval here is meant to demonstrate that something novel, transcendent, and innovative is being generated. It may be cross-sector, and it increasingly may also involve end users or impacted communities as integral partners in that research enterprise. Next slide, Chris. So just to review to make sure that we're all on the same page, basic page about convergence research. Convergence is not better than or superior to disciplinary research. Disciplinary research is also extremely important. Convergence is an approach. It's a process that does take time, and it exists on a spectrum. It's not just a binary in, out, you did it or you didn't kind of classification. It's very iterative and can build across projects and proposals, even phases of a project. Convergence opens up the problem and solution space, which can be somewhat of an uncomfortable feeling, but by doing so, you also invite the possibility of finding new solution possibilities. And then finally, again, convergence research can involve basic fundamental science. And in fact, it can be the building blocks of a fantastic convergence project effort. So next slide. Okay, now to help solidify some of this information, Olya and Andrew have been kind enough to share some examples of convergence research from their own experiences. So I think from here, I'll pass it on to Olya.
Yeah, thanks, Brenda. And so Chris, could you just for one quick second get out of the presentation mode and come back to the presentation mode? I just want to make sure my last minute change is going to be projecting.
I can do that.
Perfect, thank you. It's always a little bit
Hold, please.
tricky with this Google Slides.
All right. Let's fire it back up. Share.
Awesome, thank you.
And we should be able to. Does that look right
All
for you?
right. Looks great, thank you.
Perfect.
All right, so yeah, so as Brenda mentioned, it's we have just a couple of examples that we wanted to share what this convergence could look like, and I wanted to talk about the example of extreme heat, in particular looking at heat risks and to human health, and walk through how we got started on this journey doing this convergent research, and how it evolved throughout different projects and different funding opportunities. So to get started, first of all, we were looking at identifying complex societal problem. And in this case, the problem was that heat-related mortality and morbidity are preventable, yet heat presents major risks to human health. And as we've seen, over the last decade or so, the health-related, heat-related outcomes are getting higher and higher across different cities, communities, municipalities. So we looked at this societal and scientific challenge. Then we were looking at identifying research gaps. And back when we were starting to do this work, one of the major gaps in research was understanding not only the exposure and vulnerability to extreme heat, as some previous work already has addressed, but really taking a deeper dive and understanding adaptive capacity. And I have this image of this book by Eric Kleinberg that was motivation for this work. This book's called Social Autopsy of Disaster and Chicago Heat Wave, where he basically looked at how different communities have responded to extreme heat, in what sort of social networks and social capital and capacity to cope with this event played a role in heat-related mortality in Chicago. So by using this inspiration and identifying research gaps, we started thinking about how would we do the pilot project of really kind of taking a deeper dive in this really complex issue that hasn't been extensively studied before. And we brought together different perspectives from geography, from natural hazards, and specifically with medical anthropology and public health. And in this work, we worked really closely to combine the theories, the methods, the different way of collecting data, interpreting data, and putting that data in the perspective of this the challenging problem that we wanted to look at. And so we did a pilot project in Phoenix to start developing different methods and different approaches to address this problem. Next slide, please. And so then building on this pilot, when we started identifying how can we represent adaptive capacity, especially when the data are not readily available, what kind of qualitative, quantitative data we can collect, model, maybe observe, and how would we then bring that information with other data that has been traditionally measured and modeled using either remote sensing methods or numerical model methods or some other more quantitative spatial methods. And so we put together this framework. And the reason I wanted to emphasize this framework, because it helped us to think through like what information would we need to start addressing this problem. We might not have all the answers, we might not have all the information, representing every box in this framework. But this framework created a roadmap, and that roadmap really helped us to think about when the funding comes, if we have funding opportunities, how we can start addressing different aspects of this framework to build the knowledge to address this really complex issue that requires very diverse perspective and very diverse disciplines. And an opportunity came, came around with the NASA funding. So we were, fortunate enough to get funding, $1.5 million from NASA to look at this issue of understanding extreme heat and present and future climates, and specifically focusing on vulnerability and unpacking all of those different aspects of the framework, but not all of them, some of them. But by doing so, we started to deeply integrate additional disciplines. We started with geography, medical anthropology, hazards work, and we started bringing together additional disciplines from meteorology, remote sensing, climate science, land use, land cover, statistics, public health, and also bringing stakeholders as partners. And our public health department partners were the co-PIs on this funded project. So it was a really meaningful collaboration with the stakeholders in this work. The postdocs, I would really like to emphasize the role of postdocs on this project, because of course, everybody's busy, in RAL and working on multiple things. But when we had postdocs, we had staff who were dedicated to think about this problem and to think about the connections between different aspects of this work. And so that was their job for 2 years, to really think about, how do I represent this data? How do I model something that maybe were collected through a survey instead of, collected through traditional, more quantitative or census-based type of approaches. And so having the capacity of the postdocs, kind of being the glue between different parts of the project, and having this overarching roadmap and framework that would allow us to start really deeply exploring those connections were really the key. And another important aspect was really frequent and regular conversations and the course corrections that needed, especially when we talk to stakeholders about the usability of the outputs and the meaningfulness of the data. Next slide, please. And so we finished that project, and then we had another opportunity to apply for more funding. And in that case, the funding was available from EPA, and we got $1 million from EPA. Now expanding this, both conceptual and analytical framework, to bring together additional information from air quality, and now also focusing not only the outdoor exposure to heat and air quality, but also indoor exposure and the health outcomes. And so this framework was expanded by bringing additional expertise and perspectives. Again, we have kind of all the previous components that we've already been building through the previous work. And now we're bringing perspectives from building science and engineering, especially when we want to know how do people interact with their indoor environment. Epidemiology, again, we have climate science, and then also atmospheric chemistry. Because we're not only looking at interaction between physical properties and the human properties, but we're looking also at the interactions between heat and ozone. We're looking at the interactions between indoor and outdoor, all kinds of building exchange, building and outdoor environment exchange situations. And so again, expanding this in much more deep and convergent ways. And again, just cannot emphasize again regular conversations, because without those conversations, we would have not developed some of the novel approaches. Because when we wrote this proposal, we all came with existing ideas, because obviously when you apply for funding, you have to convince reviewers that you know what you're doing and how you're going to be doing this work. But by talking to each other, we were able to think about different ways we want to integrate the data, build models in ways that we have not thought about before, and create the outcomes that were influential in policy and public health interventions. And again, the graduate students and postdocs are absolute key, because when somebody has 2-3 years to focus on this problem and to think about the connections and thinking about the innovation at the intersections of this discipline, that could really drive innovation. And I just wanted to mention, like what also makes this potential, this example convergent, because we can also look at the outputs. And I think the outputs was input on policy. We had over 25 publications, kind of, through this arc of, research that we've done. In the publications, I also wanted to mention, because we had lead authors representing different disciplines. We had papers with lead authors from chemistry, from epidemiology, from social sciences, from remote sensing. And that shows that, each particular discipline gains something from working with other disciplines. So they can publish great innovative work in peer-reviewed journals. So it could advance their science, but bringing together scientific perspectives from other disciplines. And of course, we had those interdisciplinary work as well. That led to new proposals because, again, through these conversations, we uncovered a lot more interesting questions. And it actually motivated new career directions. So we had, again, our students and postdocs, when they were thinking that they were working in that space, several people, created a whole different career pathways that they even haven't thought about before. So I will stop here.
Thanks, Olya. And I'm going to talk about an example that some of you may have seen from, gosh, just a couple of weeks ago. Feels like a lifetime ago. This is an NSF NCAR Early Career Innovator project. So on the scale of what Olya just presented, this is like her first slide, the pilot phase of a hopefully multi-million dollar kind of program to come, right? But I think we really have laid a lot of groundwork for a really strong foundation of what I think is a good example of convergence or close to convergence research. So anyway, the Early Career Innovator program, if you're not familiar with it, it's kind of a really cool way to bring different sciences to NCAR and leverage our expertise on kind of the atmospheric, climate, earth system science modeling, and bringing in faculty from geography, social science, ecology, other kind of things that aren't necessarily in our breadth of expertise, and bring them together to try to work on pilot projects that then could lead to more new directions, new science, learning how to better improve our models, learning how to improve our science. So hopefully a two-way exchange, which kind of fits with the convergence theme. And this project was with Cleo Wolfel-Erskine, apologies, Cleo. He was a professor at University of Washington, switched to the University of California during the project. And this was a pandemic project, so actually, Olya hit the time reference a lot. And so we kind of were forced into, almost a state of slowness for the first couple of years of the project, just because we were in a whole new world of pandemic science. Not that we were close together anyway, but now everybody was remote. It was hard for their team to even get out into the community, and the community is. Cleo had a really long-standing relationship with the Karuk tribe, which sits on the middle Klamath River. So the Klamath River is here. If you can see the really small inset, it's essentially Northern California, Southern Oregon. So a coastal watershed. And if you're familiar with the recent news, this was the river that just had multiple dams removed, so we can actually have wild salmon run. And the Karuk salmon is a critical part of their heritage. Also, they've been on the land for, tens of thousands of years. They have very deep local knowledge, indigenous knowledge of land management, living with the river, and how forest management, land management interacts with stream flow and river health. And so this essentially was kind of framed in this context of climate change and hydrology. And specifically, as we got into the project even more, it was really, how can land management, specifically prescribed burning, buffer climate change? How could it be like a resilience tool? And this really took a deep integration of social science, local ecological knowledge, fire science, hydrology, earth system modeling. And over that first pandemic year, we kind of just had lots of discussions and iterations trying to build this kind of common understanding, right? Because Cleo's group was coming from a social science, ecology background, working with indigenous communities, talking with the indigenous communities a couple of times ourselves, going into community once we were able to do that again, was all part of the process. And so I think if I can go forward here. Yep, great. I do want to note though, even though we had all this iteration with community members and with Cleo's team, who was really tuned into the community, we did have a formal workshop with the community and presented essentially what we thought was the right path. And this goes to the course correction idea that Olya brought up. So this was at the point of like presenting some initial model results, talking about what we thought was going to come next as far as like modeling climate change. And we really had a lot of hard questions from the community, which is great, right? There's been a long history of trust issues with Western perspectives, indigenous perspectives, et cetera. And so we took a little while to regroup after that, and then we shifted even further into this fire-centric work. So we actually brought in a fire expert, Danielle Tuma, who's now at the University of Texas. So we made the course corrections to the project to bring in even different expertise, right? So we were aware of our limitations and said, okay, we gotta do better here. You know, we think we knew what we were gonna do, and it's gonna change a little bit. We also then spent a lot of effort working with the communities to develop these essentially land cover change scenarios. So looking at the tools that we had, it was the CTSM or CLM, so the Community Terrestrial Systems Model, essentially the land model that sits in CSM, the Community Earth System Model here at NCAR. It has, you know, all of the complex vegetation, all of the complex fire modeling that is in there, but it's really was not fit for our applications where the communities wanted to understand at the landscape scale, the watershed scale along the Klamath, how would changes in vegetation from fires naturally occurring or landscape fires put on by the communities and other, you know, mechanical interventions, how would that actually change the responses of these tributaries that are critical for salmon spawning. And so that's really not something you can do with the kind of large scale course models and with all of the assumptions that come with that. So you have a large scale model, your fire model assumes certain things, your vegetation model assumes certain things. And so we had to work within that framework to try to do the best we could because we were only on a pilot project, you know, a few $100,000 kind of order. So we worked with the community members, the community experts from the Karuk, DNR, other community members, and tried to understand how their management practices would translate into actually modifying all of the inputs that go into the vegetation model for CTSM. And so now we've gotten to the point, I'm not going to show that on here, but we've gotten to the point of doing the runs. We can kind of understand how the different choices of land management through the 21st century would impact stream flow. And it is actually showing some really interesting results that we're writing up now. So there's both social science papers that are being developed and then science, kind of technical science papers on hydrology and climate change response. And really the hope then now is we're starting to develop new proposal ideas and kind of try to build this out as how can we really push the two-way framework with model development for CTSM, CLM, and we're thinking about all the high-res fire modeling that RAL does, but thinking about that on climate timescales, right? We can do a high-res fire for a few days, but how do we take that kind of information and turn that into the climate timescale and landscape changes and evolution? And so I will stop there. I think that was my last slide. Yep.
We have a question break, and we have one online. We have use of different languages / approaches across disciplines pose inherent challenges to convergent science, e.g. vehicular activity assumptions widely accepted by climate modeling community are unacceptable to transport demand modeling community. Did you face such issues, and how do you address them? Is it specifically for Andy, Olya, both?
I don't know, Olya, do you want to go first?
You can go ahead, Andy.
Yeah. So I think that's where it really took us a long time to spin this project up, is because we had kind of, as much as we talked, we had monthly calls and other special calls and things. You just don't even realize how much you're talking past each other You just have these assumed meanings behind words that are the same or similar, right? And then once you dig into what those assumptions are, it actually means like a totally different outcome, which is what you're alluding to there. So it really, it took us, I think, a few rounds of iteration and kind of thinking about maybe we don't actually have the problem as well defined as we wanted, and hearing from the community multiple times, hearing from the decision makers in the communities multiple times to really try to get a handle on, okay, when you say fire and climate change, what do you actually specifically want out of that broad problem?
Olia, do you have anything you want to add right now?
I think Andy described it really well. I think that's just, again, part of the process is to taking the time to learn, what others mean, when they use different terminology. And sometimes, it takes a few iterations, to get it right. So, but I think especially when we work on the issue of scale, because like what's high resolution or what, when we think about scale, so that's always a big issue. Even when we talk to decision makers in terms of like what is the neighborhood scale, what is the community scale, like how do you define community? So I think a lot of these kind of things shouldn't be underestimated, because then it takes time to get to a point where you start speaking the same language.
One thing I'll add to that, because I think it is such a great question, is I think, probably Olia and Andy haven't touched on this directly, but it seems like it's so implicit in these projects, is that you have to have leadership who's kind of cued to sort of identify when maybe there are people talking past each other. Sometimes it's obvious, and I think sometimes it's not. And I think you can have intentions to articulate your definitions about a lot of things. And Olia and I actually worked on a project years ago where we did that. And still, you can be 3 or 4 years in and realize there's misconceptions or different conceptions to something, and to not consider that a failure. It just sort of is another indication that, like, oh, you've gone to that next level of maybe people are thinking about something differently. And so that's then an opportunity to continue to kind of unpack or think about the different, I think, Rajesh, your question was around language and terminology, but I think this also reflects the idea of like concepts and methods and how do we utilize different tools and approaches. So I think kind of recognizing that it does take time, it's iterative, you're gonna do 2 steps forward, 1 step back a lot, and to have people who are helping set the tone that's okay, right? That's where that leadership comes in. It's not a problem. It's actually a success in many ways.
Go for it. Well, we have one in the room. We're going to get the microphone too. Go for it.
Okay. Thanks. That was really interesting and impressive. The 2 projects that y'all talked about, it seemed to be that they were multi-year projects with a good funding. So in those cases, it's feasible to integrate multiple discipline types. However, for like some of the smaller projects, or as researchers are starting to get, undergrad work or graduate work, or people are starting to get their feet wet with maybe $100,000 projects, at least coming from the sociohydrology international community, we're trying to push earlier education in these types of things, because as earth system scientists, everything we do impacts people and planet. And so having not even one social science class in undergraduate education, or not even one ecological class, or as a hydrologist, I didn't have one single weather class. These kinds of things where I know you can't change institutions overnight, but we're hoping that this type of training doesn't come purely from on-the-job training, where you happen to be lucky enough to be on one of these projects and you learn from your colleagues. Do you see any opportunities, or how might that look to make some of these words that we maybe are confused because we were trained differently become more common knowledge, common lingo over the decades, especially if NCAR is going to be a leader in this space?
Who wants to tackle that one?
I'm just trying to be the that's a great question, comment. Yeah, I don't know what we have the potential audience right through the UCAR members, and those are focused on atmospheric science programs, but there is potential to make suggestions on curriculum. It's a yin and a yang, because there's already a lot of demands on learning different things. And
might be able to comment on this point from 18 years. So in my former academic life, I was 18 years at a university. So it was very interesting kind of how my career evolved goes to the spirit of your question, which is when I came to the University of Arizona, I entered in the Department of Atmospheric Sciences. And then we later merged with hydrology. And then we became the Department of Hydrology and Atmospheric Sciences. So the motivation for that was that we wanted ostensibly to merge the expertise in atmospheric science and hydrology for this new emergent thing of hydrometeorology, which is actually a centerpiece of this lab. So many of our students that studied hydrometeorology had very deep interactions with this lab, including some of my own students. There was a lot of opportunity to do that, and I think we were one of the few institutions in the US that was thinking in this way and moving in this direction, and to actually establish a new graduate program and minor program that students would have to take courses from both disciplines, recognizing this was a newly emergent thing. So that was great, but then the challenges were that university structures can tend to be very rigid. And so unless there is some sort of really good facilitation mechanism to get faculty and different departments working together on curriculum and academic practice, it can be really challenging, because just the same as we have our own silos within the labs, here there are silos within departments of universities. And so you have to go through this process of breaking down the silos. So what you're talking about in sort of the confidence and the trust building exercises in the initial phase of the research, in convergent research, imagine then you have to do that, like to develop a whole new academic program that is going to modify courses, maybe create new courses, maybe push faculty to teach things that they've never done before, or collaborate with new people. And so there is inherent resistance to doing that. So there's a lot of opportunity there, but when you actually do this in practice, at the scale of like the nuts and bolts of creating new academic programs and training new cadres of students, it's hard. It's really hard.
One other thing I'll add to that, in addition to what Chris said, is I think there were a couple of questions embedded in your question, but at NCAR, I think there's a role that the program can play here, and we've been talking not just in the program, in the Convergence Science program, but across different programs about workforce development for NCAR scientists and for the broader community. And I think, Chris gave such a great example of some concrete programs and developing new programs. But I think if you also transcend up a level, part of it is just developing skills to work in teams, right? And what that requires. Because, for instance, I got involved in an AI institute a few years ago. I never would have known that I needed to learn some of this language and learn some of the technical details of that. And so I don't know that you can get formally trained in all those things, but I'm not formally trained. I've learned the skills that I need when I'm going in different spaces to tackle different problems and working with different people. I loved Olya's example of how they started with medical anthropology and geography and public health, but then also expanded into land use and remote sensing and all those other kinds of things. So as the problems evolve, or as you tackle new problems in this space, you're going to be working with different people and having to learn different languages and how to work together. So it's almost like the skills to do that, I think, is what's important. And I think that's probably reflected in so much of the example Chris describes too.
I think, just a rejoinder to that is all of those things that Julie was talking about, like forming teams, being open to learning new things, taking training, learning new disciplines, for lack of a better word, trial by fire. I had to learn hydrology trial by fire. Like that takes a special kind of person that is willing to take risks, that is a little open to meeting different kinds of people and communicating across disciplinary boundaries. And in my experience, some people can do this really well, and some people are so disciplinarily siloed, they cannot do it at all. And the world's a big place. Like there's space for everyone, but I think we have to have a recognition that this is not everybody's bag, nor should we expect it to be.
Yeah, and these are good questions and discussion. We got some content left. So I want to pass it to Kim to get started talking about the program. And if we have more time at the end, we can come back to it. But also, Kim, knowing that we've got 17 minutes, the rest of y'all are left, keeping it pretty high level is probably in our favor, but I'll let you take it away.
Yep. Can you hear me okay?
Yeah.
Yeah, and you did cover a little bit of this in the beginning, Chris. So I'll just touch back in on the vision of the Convergence Science Program. Again, for NCAR to be a place where convergence research is deeply understood, valued, and supported, and for NCAR to reflect its FFRDC role pertaining to convergence research. So that's the vision is that we would be conducting strategically important and challenging convergence research, enabling it, as the discussion was alluding to there, through training, mentoring, and other workforce development skills. And then thinking about what the key needs are to serve NCAR in the broader community. Next slide. And so kind of building, kind of making sure we start with it from a point of clarity, a starting point of having a clear understanding of convergence research for NSF NCAR, including what it is, how it's done, and what it yields. From there, building a framework for robust and sustainable capacity at multiple levels of the organization to really be able to support and enable and conduct convergence research. And then from there, we can grow and take on some of these science problems that are strategically important and potentially high risk. Okay, next slide. A big part of this is developing a community of practice. And if you're not familiar with that term, this is a nice definition. Communities of practice are groups of people who share a concern or a passion for something they do and learn how to do it better as they interact regularly. So within Convergence Science Program, there is an interest network, which is a broader network of our colleagues with an interest in convergence who want to learn about what's happening with the Convergence Science Program and share knowledge back, but don't necessarily have a prescribed role beyond that. So it's kind of a network to share and learn from, and then also to build relationships in. And then let's go ahead and go to the next slide. And then we have the Convergence ambassadors. And as Chris said in the beginning, Olya and Brenda are on the leadership team, and Julie, well, Olya and Brenda are from RAL. And then your ambassadors are myself and Shima Sams and Andy Newman. And our role is to engage in training and mentorship related to convergence. to serve as ambassadors between the Convergence Science Program and the leaders of that program and our home lab or program, and to really help build relationships to foster future convergence research. Okay, next one. The ambassadors have been divvied up into these into different working groups to be able to really dig in deep to different aspects of the Convergence Science Program. So briefly, those 5 are listed here. One is unpacking what convergence is and how to do it over time. Another group is working on strategic communication with labs and programs. A third group is working on funding and partnerships for convergence. Another is doing valuing and evaluating convergence. And then another is doing data and outputs for convergence. And we'll go through one by one, but keeping it high level. This is working group 3 that I'm on, that's working really exactly on what the title says, on strategic communication with labs and programs. So thinking about knowledge exchange. This group helped with the interest network kickoff and coordinating meetings to help folks understand what the Convergence Science Program is all about and help build those relationships. Next slide. And then I'm also in working group 4, which is the data and outputs for convergence group that's led by Andreas Schumacher. And this group is focusing on things like data collection, integration, storage, management, and access, which can be complex and challenging in this space, as the question earlier indicated. We're also talking about things like creating open and accessible science and data sovereignty. We've already connected with some programmatic efforts such as Data Commons, the GIS program, and Rising Voices Changing Coasts. We're doing a lit review to see how different data have been combined and integrated in convergence research. And there's some scoping for possible data-driven convergence accelerator event for a convergence accelerator. I can't talk. Convergence accelerator event. And with that, I'm going to pass it along, I believe, to Shima. Is that right?
The mic up there should work too.
It's better. Hi, everyone. My name is Shima Shams. I'm a project scientist here at RAL. And I'm going to cover 2 of the working groups that I'm involved and a little bit more interesting content. So one of the working group that we have is focused on funding and partnership. And I think that's very interesting and important, especially to RAL, that we have a lot of base-funded scientists. So here we are reviewing different grant solicitations, seeing which grants are supporting directly or indirectly convergence research. It has a lot of a component to it. Even the wording convergence might not be in certain solicitations, how to identify that a concept of convergence fit in a proposals, and then what are the existing partnership and proposal that already got accepted, and how people approached it through the organization to work on this. So we are drafting a lesson learned summary from the existing projects and what funding was available to NCAR scientists. The other working group is focusing on value and evaluating convergence. And so on the valuing is how the organization is really supporting the convergence effort. Is it passive? Is it active? What does it mean in any of these contexts, the support? And then the true definition of convergence is also very important, and on different lit review you see different definitions. We are focused on NSF definition, but even just unfolding the true meaning of that, and as Brenda also explained in the beginning, it is not a binary thing, but what does it mean when we can say it is a convergence effort? to what level people need to step into it to feel comfortable, and then once we have it, how to really evaluate it, because there is a lot of extra step compared to the conventional way of doing research, how we can really appreciate that time and effort that is put into. So for doing that, we are also working with different programs in NCAR, such as SAM and the Ps, and we want to see how we can really have some metrics to value that. Another important part of these working groups is connection to, especially the working group that focus on the definition, is on the strategic plan. And a lot of people really contributed to the recent strategic plan. One of the teams that the concept of convergence is really manifested is Team 3, where it talks about the enhancing societal resilience, meaning that it wants to reflect on ongoing efforts, but also wants to prioritize exploring new research directions, take risk, and address gaps in foster new innovations. And to do so, the activities planned are strengthening the interdisciplinary and convergent work, and to be able to tackle complex research question and expanding community center and use-inspired research. And so aside from all of the efforts that has been put to a strategic plan from leadership and ambassador side of the Convergence working groups and the whole RAL, there are other activities and initiatives in NCAR that have a lot of overlap and connection with the essence of Convergence. We're working with these working groups and initiatives such as the Air System Predictability Across Times Scale Early Career Innovative Program. That's what Andy introduced as one of his projects. And also the NEST, that is a new concept that if goes through could be a good example of how convergence work could be facilitated. And aside from those, I think one of the prior objectives of Convergence program was to really increase the cross-lab collaboration, and having ambassadors from all lab was really successful even at that stage of the work. And then we are also working with different UCAR and NCAR labs such as DEI, EDC, and Unidata, and then the hope is to further expand it to outside communities as well. And with that, we have some question, and Chris has more content.
Yeah. I'm going to try to wrap it up really quick so we have a few minutes for questions, hopefully. But I want to hit on a few things of where we're going. So you heard a lot of those working groups, and you see there's some big topics like how do we fund this? How do we evaluate it and evaluate here at our organization? What does the data look like? How do we communicate about all these really complicated things? So we'll keep going with those. But we're also interested in learning back, right? So we've emphasized a lot of the goal here is it's around community, right? So building more of the bottom up, right? So answering questions about education. What do we need here? How do we be a community leader here? So listening for these types of things, like where do you see the gaps are that this program could address? And that could be things like finding the right examples that could really explain this well. And so kind of fostering this really engaged cross-organization, bottom-up approach to this. So interested in working with you all. More about these examples, the challenges, the potential, and all these different types of things as we go. So you'll definitely hear back from us in different ways. But I also want to highlight too that we have another part of that community of practice that we heard earlier is that you can join our community of practice through the interest network. So you have the link here. It's also on our website if you just, NCAR Convergence, and we'll send these slides out with the recording too, but just sign up, right? It's a low lift effort. We're not asking you to commit to anything. You can just stay informed, see what events are out there, decide if you have time for it as you go, and just be a way to stay engaged. We'll probably start to reach out to folks, have our quarterly meetings there, talking one about funding, probably coming up soon. Those types of things. Just join it, right? You can always, if you don't want to keep on it, you can unsubscribe later, but a good way to stay connected, right? Through your ambassadors and through this interest network email. And then also just noting, this is the email address we have. If you have questions, you want to reach the leadership team, use that one. And you can also find out more information, including how to get signed up for that interest network on our website there. But I want to make sure we have time to just acknowledge a lot of the folks that put time and effort into these, a lot of these discussions, through meeting with Julie in the beginning days, all through to making these presentations happen. And a big shout out to your RAL team who did a quick, pivot and run around to make this presentation happen in just a couple of days. So thank you all, and I have a question on Slido. I'll hit that one first, but if any folks have questions too, we'll get to those as well. Thanks. So the question we have is, based on your knowledge, to what extent is the education enterprise evolving to foster inter/transdisciplinary education and research? I think this kind of hits on the question from earlier too. I think there's interest, in a lot of places, like it's there, but I don't know if the structure exists in a lot of places, right? We're cluster hires across many different places. You're all going to work together and kind of getting degrees in different spaces. From my experience, a lot of it happens through kind of being those grad assistantships or postdocs like Olya mentioned, where you get to put in this place where you get to explore, right? So maybe you have advisors and leaders that you can refer to that are across different disciplines, and you get to exist at that nexus is a really strong place. But also emphasizing that like the educational component we'll get to is, and Julie mentioned this too, but we're working with like education, the EDC group is also where we have an ambassador, right? We have someone there working with Rebecca Hacker and thinking about what is the student opportunities? What is our role here? How can people get a convergence experience on the same time scale as a disciplinary one? Trying to figure those things out too. Any other questions?
I just want to add something else to Matthias's question in response to that. I think we can also do more, Matthias, to work with professional societies. So for instance, I was in the AMS summer community meeting. Is that right? Yeah, it was a summer community meeting. And they were talking about the future of the AMS curriculum. And we talked there a little bit about the idea of team science and how that could potentially be built into the curriculum as well. So that's just one professional society. Could certainly work with AGU. So that's another mechanism I think that we can think more about. I also know the national academies are doing a lot around this right now. Actually, I keep getting emails around this. So I think that'll be interesting to see how that propagates. So.
Yeah, so there's sort of like stages of doing this. The first is at least getting people to talk about it, share their ideas, share their research, then develop individual projects, then motivate that to, well, what do we do at the level of like, lab priorities or priorities within colleges or departments and universities. Then you get to some pivot point where then it grows enough to say, what do we need to do to support this from a resourcing standpoint, and create an organizational structure that supports it. So there's a lot in the advocacy piece that has to happen to do things like motivate internal funding opportunities, to motivate new academic programs, new research units at universities that then would have specific, let's say, scholarship or fellowship opportunities to support activities in convergent science. Mm-hmm. So there's sort of a pipeline or a path from the initial interest and people talking in a regularized way to motivating specific opportunities to motivating like institutional change and sustained opportunity.
Yeah. Convergence, yeah, that's Julie's comment. A lot of this convergence work on the programmatic level is part of the convergence process. Go for it.
All right. Hopefully not at the risk of going too late, but I just had a question about Olya and Andy presented really nice presentations on these efforts that were federally funded. Have you found that there are also state-supported convergent science projects in the state of Colorado or other states that might be successful to look into for our lab?
I don't have an example specifically from the atmospheric science domain, but I also know like in response to fires, a lot of cities and communities are really excited for whatever solutions you have. So like my partner is a plant ecologist and is working with different communities, different soil scientists, different like managers to try to hit that. And it's a very localized funding. So like it comes from Boulder City, Boulder County, other places, just seed granting that then started to like a joint fire science program. So I think it depends on like if you can take that problem frame, right? If people are really motivated and have funding around a problem, I think convergence can be a solution. It's like like, you don't necessarily have to expect the state to fund convergence, but if they want to fund a problem, that might be a better frame. It might not say that term, but if you're thinking this is a really big challenge, that could be an opportunity to find that local funding that you can use that approach for.
Or that you find a consortium
Yeah.
of people that can get together and then all pool that. And what's nice about that is then you can get people that that you can somewhat decouple, like the resourcing question from the community needs question. So you might have really impacted community members, but they don't have the resources like to stand up a project, but they can be part of a group within of community participants where their voices can be heard.
Totally. And I'm going to be conscious that we are 2 minutes over, but I want to make sure Kim's question gets on the record of, do you think there would be interest, in and funding for a workshop on developing skills for this? I think there is room for some exposure in that way, even if it's just a starting point. And maybe that's a good feeder to this will be a topic for strategic planning for RAL, and that's something you can bring in those breakout sessions and discussion. But thank you everyone for your time. I don't want to keep you too far over, and hope you have a great rest of your day. Any other closing remarks, we can add them on, but feel free to run if you need to.
Yeah, and thank you all very much. And just a comment from RAL leadership side. We are having these series of seminars. So this is the first on convergent science. We're going to have the next one on the summary of RAL futures. So these are both prelude orientation information that we're going to need for the upcoming RAL retreat on the 21st. So if you can kind of create a buzz among your colleagues in the lab, a prompt to have them look at these materials, I would appreciate it for the groups here if you could at least make your presentations available so they can be distributed to the program directors and then socialized in those groups, and also make the recording available. So thank you.
Thank you all. And thank you to tech team for making this work, even though we didn't have the proper setup and organization system. Appreciate it.